Good morning. Welcome everybody for our dev recap. This is the call where our development reference units share what they did in the last month. So we have a lot of nice news to share with you. I just said that there are some nice articles on our blog in the our website. So cartesi.io/blog. So there you can have a very nice series called Grokking. So the last one was Grokking Cartesi Node. We have Grokking Cartesi Virtual Machine and also Grokking Rollups in two parts. These are very nice articles for you to understand better our solution, develop Cartesi is bringing to the ecosystem. Okay, so take a read. Uh, Oh, thanks a lot, Felipe. Felipe is sharing in the chat the links for the articles that I mentioned. Okay. So let's start our call. I would like to invite our special guest, Brandon, to explain for us the technical evolution process that Cartesi is building, and it will be the way that we will give opportunity for our roadmap to be decentralized and have the contributions of our community. So, Randall, welcome to the stage. The mic is yours.
Thanks, Claudio. Hey, everyone. So I'll be real brief, but I wanted to, as Claudio said, introduce a new process that the ecosystem is implementing for creating what we're calling the technical evolution plan, which is the Cartesi ecosystem's collective roadmap in the mainnet era, created in a decentralized manner. So I'll be acting as a non-voting member, as the secretary of what we're calling the Technical Vision Council. And just a quick recap on the process. The process will have three separate components. The first is the Technical Vision Forum, which you can find on governance.cartesi.io. And the idea is that any proposals that core developers or community members, any technical features that anyone would like to see included in the ecosystem's collective development plan. The process begins by putting a proposal, starting a thread in the governance forum on the technical vision forum. That proposal would then be open for comment and feedback, both by other core developers as well as any interested community member. The second stage of the process will be the Technical Vision Council, and the council's role will be to deliberate and discuss items that have been presented in the forum. So after a proposal goes to the forum and has been subject to a comment period by other developers and community members, the Technical Vision Council will have meetings to discuss and vote on whether or not certain proposals or features should be included in the ecosystem's development plan. And then the third stage of the process would be the creation of the development plan itself. And Claudio from the Technical Coordination Unit, along with Milton, their role to finalize the process will be to take items and features that have been discussed by the Vision Council and voted for inclusion in the plan. Claudia and Milton will then memorialize those features in a collective plan for the ecosystem that can act as a guidepost to get everyone rowing in the same direction. So that's the process in a nutshell. I would encourage all developers and other community members who have any proposals for features, technical features that you'd like to see included in the ecosystem's plan, to go over to governance.cartesi.io and open up a thread. Thanks, Claudio.
Okay, Thank you, Brandon, to bring this. Vitor Ives shared the link for the governance forum. There we have a description with diagrams of the process that Brandon just explained. So take a look. And let's start our updates. Today is a cloudy and very hot day here in Brazil. So please let us know from where you are now. Give a good morning and say where you are. Let's start our updates. Who will be the first one? Let's see who is excited to share the unit's news. Like to go, Vitor? Great. Come on, Vitor.
Hello.
Hello.
Sure. Let's share my screen. Hello, guys. My name is Victor. I'll present the dev updates for the work done in November. Just a minute. Okay. This will be a shorter update than the last one, so people can talk calmly after and no rush. All right. The agenda for today is to go through some fixes and improvements that were done on the emulator. Also, some progress of the microarchitecture. There were a lot of small changes on the kernel tools and the toolchain. And there is this two tests, the output verification and the hypervisor, that are not going in on this release, but they are being worked at full speed. Okay, to start with the fix and improvements, we have the machine emulator SDK coming this week with a lot of improvements. Eduardo did a great work adjusting the emulator repository and libcartesi, so it now can be cross-compiled, packaged, and usable in various platforms. And it did test that, and the Cartesi machine now boots on Windows, was Android, FreeBSD, and it did DOS for fun, DOS. And part of this work was to isolate all OS-related functions into a single OS file. Also, as the machine emulator was updated, there's some work that had to be done on the server manager part. So the server manager was upgraded to use the latest machine emulator, and the other items there are requests from the Sonodo team. One, so they can check the version on the command line, and the other one is as they are using the server manager on another container, they can now look for the Cartesi machine installed in the path. And for the microarchitecture, I'll ask Pernambuco to talk a little bit.
Hi, everyone. Can you hear me? Hello?
Yes, clear.
Okay, thank you. So this will be quick. So there was this very big change on all aspects related to microarchitecture, and which the code review has, I suppose, finished. So everything has been addressed, ready to merge. There's that. So there's also changes in this machine solidity step for adjusting it for the new changes. And now big shout out to Stephen here, who did the most most difficult work on this aspect. And right now we are studying options for optimizing the computation of the Merkle tree in the machine, not only in the microarchitecture, but in the machine in general. So that's pretty much it. Victor, thank you.
Okay, thank you, Marcus. The next is kernel tools and toolchain. As I said, there are a lot of changes. I'll ask Marcelo to talk a little bit about that.
Sure. Hi, everyone. So about kernel tools and toolchain, updated the kernel from 5.15 to 6.5. And in the toolchain, a bunch of packages got updated as well. We also are distributing our fork of chainx2fs and renamed it with an X, prefixing X to avoid confusion, so you know which options are valid, which aren't. Also on the kernel, the migration to OpenSPI, it allows us, it's an Uber BIOS equivalent, I guess. It's a low-level stuff and allows us to forward application exit status. And also when the kernel panics, you know the Cartesi machine has a way to know what happened and the execution failed. The image rootfs being removed from the SDK in favor of the Docker building system for the images, and it's based on Ubuntu. And yeah, this is an example of how the exit works. So when your application exits with some kind of exit code, gets passed through the emulator, and you can do something else with it, scripting or whatever. About output unification, there's been a little pause on the work to get the release going, and this is for the next release, so we're right back at this already. So a lot of the work is being done to move the functionality that's currently on the driver to user space. This will allow us to move faster with ideas and prototyping. The high-level API will not be affected, only the low-level one that talks to the kernel. And also a shout out to Sophia. Thank you for updating the rollup HTTP server. And yeah, hope the work is going well. And that's it for me. Back to you, Victor.
All right, thank you, Marcelo. And for the last part, I'll ask Alex to talk a little bit about the hypervisor progress. Alex?
Hello,
Okay,
Alex.
do you hear me now?
Yes.
Yes.
Yeah, cool. So thank you. I couldn't take the stage. So regarding hypervisor project product progress, first of all, the guys already mentioned that we've merged the new OpenSPI and kernel, and this is very important, the groundwork for the hypervisor. So now people can try it more easily. This is very exciting. So then currently we're working on the Sunodo support for the hypervisor. So there are some technical difficulties regarding the way the hypervisor applications should be distributed. So we are working on the proposal for the Sunodo team right now. That's it. Thank you.
All right. Thank you, Alex. So that's it. Claudio, thank you.
Thank you, Victor. Thank you, all the machine emulator members. So let's go, Danilo, Pedro, Deneu, Anderson.
Hello, everyone.
Hello.
Let me bring up the slides. Looks like I can't share my screen for some reason. The button is disabled. Do I need any special permission?
Yeah, it's also disabled for me.
Has somebody forgotten to stop sharing, Victor? If you can go back on stage and then unshare and.
Victor?
Yeah, I can share now. Just a second. Okay, these are the slides for a few units. I would invite first Pedro to the stage for the contracts part.
Hello, everyone. Can you guys hear me?
Yeah.
Yes, Pedro.
Can you move through the animations, Danilo, please? Yeah, thank you. So we decided to scrape the 1.2 release and go straight to the 2.0 because you are going to need to redeploy contracts. So yeah, the main changes, we changed the ERC portal to reject failed transfers. That's an important feature because in the previous version, if a transfer through the portal failed, it still added an input to the dApp, sending a false flag to the dApp. But right now, there's no more flag, and if the deposit fails, the input never gets added. So now, if an input was added from the portal, the dApp can be sure that the funds were also transferred in the layer 1. And with that change, sorry, Newton, let me see this comment. Yeah, Guilherme, can you tackle the comments, please? Yeah, and also remove the success field because now it's going to be unused. Similar features in the voucher execution. Now, when the voucher execution fails, it does not return a flag anymore. It propagates the error, so it's easier to debug what happened while the voucher execution reverted. I also had a really nice talk to the Node team about the interface. And we are changing the dApp contract to implement a lot of new interfaces to help them to know how to interact with the blockchain without needing to worry about the implementation. So it's going to be a lot easier to collaborate between the two teams going forward. And we also removed several contracts related to historic contract because it was we decided to keep the dApp storage, the dApp history inside the authority. So it's one less deploy contract that we need to care about. Our claim storage is logic is gonna be contained in the contract that the authority is gonna inherit from. Yeah, so we remove the history contracts, and in progress is implementing these chain storage contracts and apply all the changes to the authority and consensus interfaces. Yeah, I think that's it. Guilherme, do you want to complement if anything? Or Zippie? Zippie is here. Probably it's too late for him.
Thanks, Pedro.
Okay, thank you.
Moving on to Dave. Are you there, Coaching?
Yes, can you hear me?
Yeah.
Yeah, okay. So first, there are the updates that we had to do to support the newer versions, new releases of the emulator. So yeah, that's the first item on the list. And now also we are going to use, since we are developing the Rust node for Dave, we need some interface with the Cartesi machine. So we're going to reuse the work that Carson has done. There's now a new repo with that work there, and we did some cleaning up that we felt was needed. Now we are developing two separate pieces of the same software, which is the dispute node, which is essentially the part of the node which knows how to fight a date dispute. This is the one that we have a version in Lua for prototyping, and now we're doing the Rust version. And we're also doing the rollup part of that, which is, well, it uses the first part essentially, and it's very like green, barely just started doing that. But yeah, it's starting. Now, this month we had DevConnect and we spoke there. We presented Dave to an audience at L2 Days. I think it was positive, and I think we're going to see the repercussions of that presentation as time goes. And finally, we've been designing how the epoch is going to look. We had a few possibilities, actually a couple possibilities, and we've settled on one which is like dynamic size, because it just seems with the better profile. We're still designing it, but I think we're closing into a solid enough high-level design to prototype something and then evaluate where to pick up from there. Yeah, that was it. Thank you.
Thank you, Coutinho. Moving to the node unit. Today, I think we have Yves to talk about the tasks and the accomplishments.
Can we hear me all right?
Yep.
Yes.
Okay. So starting with the most relevant update, there's a release candidate for version 1.2 of the node. This version brings 3 new things. There's a new service to submit the Rollups claims. The second one is related to the first, which is support for reader mode. Reader mode is basically the mode where the node doesn't submit new Rollups claims. And the third is we updated the support for the Rollups Contracts version 1.1. This version also contains some relevant bug fixes from previous node versions. Special thanks to Anderson from the Synodo unit for reporting them and helping us with the tests. And moving on to our other initiatives, we're making progress in the civil container front. We have now unified the node's configuration in a more cohesive set of environmental variables. So we have removed some duplicates and confusing names, so it'll be easier to reason about the node's config. On the testing front, we're building the infrastructure necessary to test the node without relying on the Rollups examples repository. We are creating a new CLI tool to help us with this task, similar to the front-end console we used to use. This tool will be really useful for manual testing and will also help us later when we approach our end goal, which is to automate our end-to-end tests in the future. And last but not least, we're working on the monolithic redesign of the Rollups node. Nodo is its current working title, and its major goal is to support the validation of multiple dApps in the same node instance. So we're taking the knowledge we've gathered so far with the current node to make it harder, better, faster, stronger. It's going to take a while. It is still in its early design stages, but we're really looking forward to it. These are the updates for last month on the node unit. You can, if you have any questions or doubts, reach out in the node channel or in the chat. And thanks.
Thanks, Yves. Anything to add, Lino? No. Yeah. So moving on to the Explorer unit, I can give the updates. Bruno, which is the unit lead, is not here, so I'll help him to relay the updates of the Explorer. So the Explorer, as you may already know, is deployed on the Cartesi Scan website. We have a deployment for mainnet and also deployment for the Sepolia network, accessible through cartesiscan.io. We added a few new features. The first one is the ability to not only see the inputs of the applications, but also inspect the outputs of those applications, like vouchers, notices, and reports. For that, you need to make a connection to a reader node for the dApp. So there's this new feature called dApp connectivity. We also added support to deposit Ether, in addition to deposit ERC20 for applications. There is now a dedicated page for applications, and using that page, you can quickly add new connections to check the outputs of the applications. There was a column showing the timestamp of the input. We now have an option to see the exact timestamp in addition to the age of the timestamp, and a few improvements to the UX of the ERC20 deposit forms. And in terms of work in progress, we are developing a send raw input screen and also ERC 721 NFTs. And we are taking this opportunity to also unify these deposit forms and transaction forms into a single user experience. So there are a lot of screens, so we are kind of unifying them. And we are also redesigning the homepage of the Cartesi scan. The homepage now is just a list of inputs. We are changing to show the most recent inputs and the most recent applications deployed. So stay tuned that there will be a new version soon of the homepage. Moving to the Sonoda unit. Anderson, you wanna take this or?
Sure. Can you hear me?
Yeah.
It's a quick update. Basically, we automated the process for deploying the dApps that we have on both staging and production environment. Now it's easy for us to keep it updated for the next version. That's 1.2. It's going to be a simple configuration change and everything's working. And the Rollups node chart, that's the component that we use to deploy this, is ready to the next version. That's Rollups node 1.2. We already made some tests using all the recent release candidates that Evie is mentioned, and we are ready to go. As soon as we have a final release, these dApps will be updated on the proper environments. That's it.
Thanks. And finally, on the Sonodo front, we are working mainly on the Sonodo deploy feature. Just a reminder, the Sonodo deploy is the ability to deploy applications to live networks, test nets, and mainnet. So this task is twofold. The first one is on the developer side. He needs to be able to deploy the application to the chain and select a few options, but there is also tasks on the validator side that needs to run nodes for those live applications, right? So we're working on both fronts, and we've been designing a system that uses dynamic provisioning using Kubernetes to spawn nodes for applications, because right now each application needs its own node. So we need to dynamically provision those nodes, but we are in conversation with the node unit team. So we are starting like a joint effort to, instead of doing the dynamic provisioning, to use a multi-dApp node that Yves is already mentioning in his slide. So it's gonna be easier for us, and it was kind of already in his roadmap for the future. So we are planning this together now. And finally, there is an imminent launch of the Sonodo website. I will not give more details right now, but stay tuned. It will be live soon, very soon. That's all, Claudio.
Thanks, Danilo. I would just let's take a quick brief. I see an important comment that Cynthia left on the chat. So, guys, any question is you can put on our chat. For example, if you don't know what Dave is, don't be shy. You can ask that, and we can ask Coutinho that I'm sure will be glad to answer and explain it more. I don't know if everyone noticed, but we have Cartesi machine also possible to run on Windows and Android. It was great. So if you want more details about that, please ask in the chat. So I know it's a lot of information, but don't be shy. Any question is important. That we can. The reason for this call is really to bring this information about what you're building for the community. So the chat is yours. Let's continue. Go ahead, Carlo. Welcome to the stage.
Can you guys hear me?
Yes, clearly.
Okay. Also see the screen?
Yes.
Okay, awesome. So guys, another month, another review. Let me get through the main things we've done during this month, okay? So a couple of really interesting prototypes and examples were developed. So one of those is making this template that's available on our repo, in which you can combine Aztecs Noir with Cartesi. So using this template, it has everything to verify a program that was made in Aztec Noir. So you basically program in Noir some logic, it generates a proof, and then you can verify that proof inside Cartesi. So for anyone wanting to play a bit with rollups and zero knowledge, that's a great place to start. Another thing that was done is we now have an updated version of the Echo Voucher Sonodo, which is this really simple application that whatever you throw at it, it throws the resource back using a voucher. And it's done in Sonodo and on the current version of Cartesi Rollups. Also, this one was done for especially because of Dev Connect and If Global Istanbul, basically. Right now, Sonodo has the deployment on testnets as a feature under development. So we had a workaround that's here, and people can use it to deploy Cartesi Rollups application to a testnet of their choosing. And another thing we have is a really simple package in TypeScript that implements all the interfaces to interact with the Cartesi node. So we already had a general front-end template with all the features to interact with Cartesi node, provide inputs, read out all sorts of outputs, execute vouchers, all the stuff. But it had all the stuff for generating the web pages and things. This one is a simple library, so we'll probably make a version out of that front end using this library as well. And you can get started easily on a Cartesi client using it. This one is updating this generic front end I just spoke of to also allow using the post method for inspects, which is a pretty new feature on the node. And a very interesting experiment that was done is using Celestia as a data availability to provide storage for video clips. And then inside the Cartesi machine, we had a video processor that does some processing with this video. I'll show an example later. Just reminding that we also have the high-level frameworks undergoing. So both one in Go and another one in Python. And also the specification for the communication between the front end and the back end, which is on this Cartesi API specification repo. As I said, Dev Connect also happened. And we had the team members participating on the If Global hackathon, making Liquidator dApp, which is a DeFi application. You can check it on GitHub if you want. And we also had a presentation about Cartesi's general purpose VM on the Decentralized Scaling Summit, and the presentation is available in there for anyone interested in it. So this is an example of that Celestia processing application that I showed. So this is the video that would be sent to this application. And when you send the video, we just do something like the Tug Life mem, and a process inside the Cartesi machine drops down these glasses, tracks the faces of the person, and places it on top of it. So the most simple version of it, it's already implemented and available on the repo that I showed. And yeah, I guess that's it, folks. Any questions?
Great, Carl. Thank you very much for your update. Very nice and interesting things to explore. Karsten, we want to bring in updates and news for the community. Oh, great.
Yeah,
Our mad scientist.
Screen.
Welcome.
Okay, yeah, it works. Can you see my screen at the moment?
Yes.
Yes. So today it will be me, and then also in the last part it will be Patrick, also from Zippie. Just invite him also to speak on stage. But I'll go through my very quickly 15 slides about what's going on. But long story short, as we're also doing in this call, it's important for devs to not just develop, but also go out and actually talk about what we're doing. So we've been doing a lot at K Warsaw, VM Day, and panel at VM Day, and talking a demo at the Restaking Summit, which is Eigenlayer. And as some of you know, I was talking about, somebody was asking if there's a partnership or anything, and this is not like something like that Eigenlayer is condoning us, or like a partnership or anything like this, like normally say, but I got my selfie together with the founder of Eigenlayer, and they know what Cartesi is, which is a good start. Talking about co-processors, which I think will be something coming up in topics in the next couple of months as well, also for Cartesi. I also did a talk on scaling Bitcoin together with Chainway, who's doing kind of like Bitcoin developer stuff. I also found some time together with Claudio to make a tiny podcast. And I did another one, which is Bitcoin and beer in Warsaw. And I am pretty much tired of talking now. I'm first going to do it again next year. But I would like to say that getting Doom to run on things, it's really important, and I think we should be doing more of this in the ecosystem. More practically, there's also one more thing that's coming out, which I did a whiteboard session together with a Whale Network. Now, naturally, I'm not the only one in the team, so we were during the last month, we were doing kind of like integration, seeing if we can kind of like make the same interfaces from Espresso to Celestia. We got it working on local hosts. We have it connected to testnet, but we're kind of like still kind of like figuring out how the let's say their faucets and so on work. One of the things that we have gotten working recently is that we have a Cartesi machine where we're kind of using this proto dehashing, it's called, where basically we have an IPFS daemon running inside a Cartesi machine with a special plugin developed by Niakio that basically uses the dehashing device or emulation of it as the data store for the IPFS daemon. So basically, if you're inside the Cartesi machine and you want to access something on IPFS and find its data available, because otherwise it won't work, it will actually work using existing IPFS APIs. And Patrick, are you ready to talk a little bit quickly about kind of like the real world asset stuff that we're doing? Just a quick background.
Yeah, sure. Can you hear me?
Yes.
Yeah, okay. I'm Patrick from the Zippie team, and just some background. So I'm working on this real world assets use case. And the background is I'm working on something or helping something called Air Impact. It's a digital platform for connecting reforestation developers, investors, and buyers in nature-based carbon market. And just to get like some background here. So the features like in this platform is like a report assistant. So when you have this kind of projects for carbon credits, you need to write a lot of documents. So it's just to help you with that, to reduce the write timing. And then there's a carbon calculator. So when you're going to plant your trees, you want to select, of course, the optimize your tree species, so you get the maximum amount of carbon credits. Then there's also an AI advisor to help you to select the standard and certification and different methodologies. And then there's also monitoring. So you want evidence, of course, that there's actually trees like growing, and you could use like satellite images, drones, or mobile pictures for that. And usually for these projects, they need help from the local communities, the people who are working on site, and they get salaries usually into their mobile wallets. And then the last part here, which connects with Cartesi, is the digital wallet and the carbon asset management. So when you have these projects, everything is about getting these carbon credits, planting trees and get those. These projects are usually maybe 30 years. And you don't, of course, get the credits immediately. So investors, usually you invest money maybe in projects, you get some batches of these carbon forwards. So forwards is like before they get into credits, and then when the trees grows, you get the credits, and the forwards turn into credits, and then you can you have buyers and sellers for that, and when you use the credits, it gets retired, and all this, if you want to track, of course. So you could go to the next slide, Carsten. Here, yeah. So within this work with Cartesi, the goal is to define and implement a system architecture for this real-world asset verification utilizing Cartesi verification. So we'll build a prototype for this use case with the carbon credits, and also test to integrate this into the Air Impact platform I was talking about before, and there's also a wallet solution. And then also to include this in something we call TosiScan. It's just a user interface to like an explorer to actually see the verified information, like who issued the assets, who certified it, and the ownership and the history, etc. And now during November, so we have been getting up a baseline. So there's a public GitHub repo created if someone is interested. And we had added like the previous, the current implementation that has been used into there. And then we have adapted it to store and read state using IPFS mutable file system, and also to fetch new transactions or input using the Cartesi API. And yeah, you can go to the next page. And all this will run then as this Cartesi Lambada function. And here I think Carsten could maybe give some more information about this environment.
So this is kind of like what we're playing around with, where basically, let's say, and seeing what kind of like interesting things can be done if, let's say, all the state is essentially in the IPFS. It's a little bit of a different way of doing things, but we are playing around with kind of like easy integration into sequences. Looking at how does this look like if we have, let's say, many different kind of systems like Proof of Stake, Eigendata, stuff like Dave, easy access to state through the front end, because basically everything is sitting in content addressed areas, things about archiving and so on. So it is kind of like a different way of kind of like potentially making something that's easier to start developing Cartesi applications with, by just essentially publishing something like an IPFS CID telling about your rollup and the program it needs to run. I'm not going to dive into this more, but basically kind of like
Okay.
We don't hear you, Carsten.
Hey Patrick, any demo?
this is a really bad muting interface on Discord. I will say that, but basically what we have ended up is that we basically have this working with kind of like writing the state of this function that Patrick was talking about into IPFS, and kind of like so you're able to basically directly access kind of like the state of the chain by having the latest head or the latest EID of the chain. Yeah, that's pretty much it. And since this is about recap, I'm not talking about our plans for next month, so you have to wait a month to see how that looks like. We did.
Okay. Thank you, Carsten. Thank you, Patrick. Welcome to our community. So let's go, guys. Now it's time for questions. Let me check here what we have. Hilton, how are you today in terms of questioning things? Just to know. Oh, I was interested in, it's provoking, and there it is.
Oh, there are some questions in the chat that could be addressed. So one of them is about what's the relevance of running a Cartesi machine on Windows, Android, and WebAssembly and whatnot. Who would like to take that one? Let's Diego under the bus.
Yeah.
Oh, there he is.
Am I under the bus already?
Almost.
Okay.
Only if you want.
So the Cartesi machine is our emulator, right? For the Cartesi machine, and we designed it to work on Unix, on Linux in particular, but we've been reducing the amount of dependencies that it has to make it simpler to compile for other platforms, right? And the main motivator for these changes is this desire to run our emulator inside the browser. And in order to do that, you have to compile to use WebAssembly. And so this already works right now. And so that's what we mean that it works on WebAssembly. And some of these changes, well, it turns out that it enables us to compile it for different targets, right? And so why not? If we can make it run on Windows, we did it. So also Android, and so whatever OS, I believe even Sun OS, Eduardo tried, or I mean, so you can now run our emulator pretty much anywhere you want. There's some limitations. In particular, there's an API that relies on fork, and if you rely on this API, then you need to be on Unix, on a Unix operating system. But if you don't rely on the fork part of the API, you're good to go.
So Diego, will this make it easier maybe to run development node without Docker, something like that?
So the node, unfortunately, is one of those things that depends on the fork functionality. So no, but we are working on there. I don't want to say we are working on it, but there has been some discussion on ways to remove the dependency on fork, and we think there is a path forward that shouldn't penalize people that are not running on Windows, because it's kind of unfair otherwise, right? But we think it's possible to do without, and as soon as we have that going, you guys are gonna know about it.
Nice.
Let me get out of under the bus.
Yeah, I also think that this question is interesting in terms of we can highlight how Cartesi opens the design space so people can explore more use cases than the typical and usual ones. So giving someone interested in blockchain, in Windows blockchain applications related to some Android use case. So there you have you have this possibility that you can explore more and give feedbacks for us and etc.
Yeah, to be fair, the thing already runs on Windows, right? You just need the Linux subsystem, which is something that most developers will be familiar with. And also, if you just want to run the Cartesi machine, that's fine. You can do it. It will run. What it won't be able to do is revert back to a state that it was in an efficient way, right? So we use fork for that. So we fork the machine, run it. If you want to revert, we kill the child. That's a horrible way of saying it. We kill the child, and then the parent goes back. It goes back to the parent that is unmodified, and we fork it again, and so on and so forth. This is the easiest way of implementing this. But we're working on a way to do this without the need for fork. So basically implementing the functionality ourselves.
I'd just like to add that, Diego already jumped out. One of the reasons for wanting to run this in WebAssembly is that you could do more easily things like the Doom Arena and things like that, where the game or the application can run in the browser. You can run that Cartesi machine in the browser, a full Linux OS in the browser, deterministic Linux OS. And then whatever it processes, you know that the validator node or any Cartesi node will reach the same results, the same state, and that can be really nice for certain use cases.
Max left a good question that I was also interested in more details about this integration with Aztec Noir. So Carlos is already on stage. Carlos, can you read the Max question for everyone and please give your comments?
Sure. It's can you dive deeper into Noir template integration? What are some potential interesting use cases for that? Plus an estimation of costs in generating verifying proofs. Yeah, it's a great question. So first thing is that, as I said, it allows you to combine both tags, which is something quite useful. So I'll give you a couple of cases in which we already used this combination for that. So when we made DFast, we used this to make the reputation system possible. And it's also what enables the payment system in a way in which you cannot bind a particular trip to a user. Just remembering DFS was this Uber-like rideshare service we made decentralized, and one of our main design concerns was privacy. So if you know who paid for a trip, you know that person was on the trip. If you know that someone was paid for the trip, you also know that person was on the trip. And then the trips are public. So if you have the trips and you know who was in there, you can track the person, right? So we use zero knowledge proofs to decouple payment from the trips themselves. And that allowed us to have this privacy enabled trip payment and also reputation updates, right? So we also use that to check that a given party on the ride had the reputation they said, without revealing their history and all stuff, and also updating that after a trip was done. So those are just two possible use cases, but there's a lot of stuff, right? Basically, if you need privacy, zero knowledge is always a good route to go for. You can prove that you made something with some data that you don't reveal, and then given that assertion, you can continue with some logic inside the Cartesi machine. Besides this use case and general explanation, there's also another benefit. So the verification contract that there exists on chain is quite expensive. So if you throw a stack-no-R proof on chain and you want to verify it, it costs quite some gas. And the verifier that was put inside the Cartesi machine, you just have to spend money on the call data, let's say. And it gets, if I'm not mistaken, Lino, you can correct me here, but it was like 10 times less gas to verify a proof inside Cartesi machine than on chain. So there's also this cost aspect that can be considered a valid point for using it inside the Cartesi machine.
Oh, great.
And if you use Celestia for DA, then even less, right?
Yeah, I should lower the cost even further, right? Because it's cheaper to put a chunk of data in there than on Ethereum.
Once Milton touched Celestia point, Carl, what can you say of the difference, the experimentation you are doing on Celestia and the experimentation that Karsten is doing?
So this first version that was done, I don't think there's a lot of difference because we used it, the Cartesi machine bare bones, let's put it this way. But the experiment we made could evolve into a rollups application. So that goes a different route than Carson, which I think it's based on Lambda.
Right.
Okay, thank you, Carlo.
Talking about Karsten, if he's around, do you want to go deeper into some of the things that you talked about? You said you did a whiteboard session with the Veo network. What was that about? And maybe also this topic of coprocessors that you slightly introduced but didn't actually explain. So that would be great to hear as well.
Yeah, so about so about the whiteboard session, basically they invited us to do a recorded whiteboard session where basically we went through and discussed a lot of topics about data availability and Cartesi machine, how Cartesi machine works, why is it important. So it should be quite an interesting kind of like talk to watch. My handwriting is horrible, so I'm not sure how good the whiteboarding was, but let's see how it looks like at that point. But it's basically like if you look at many other projects out there, it's a kind of good way to kind of like, let's say, do cross marketing to some extent and sharing content. And I think we should actually consider to do a few of those ourselves with different projects when we get the opportunity for doing it. So. And the second thing was about co-processors and so on, because the demo that we did in Restaking Summit was basically showing, like the title of the presentation was like high economic security, replicatable deterministic computation, which is a bit of a mouthful. But basically, using something like Eigenlayer, you can go out and get a lot of restaked value. And about restaking, please go to Eigenlayer and see how they define that exactly. But basically, it's a way to get a lot of economic security for your proof of stake application, for example. And what we did in the demo was basically demonstrating, okay, so how could it look like if we had a Cartesi machine replicated, because it's deterministic, right, across many nodes that vote on it, and they're slashed essentially if they're misbehaving, which might be useful for a more co-processor-like mode, where that instead of, let's say, having a rollup necessarily, you would outsource computation to a bunch of nodes that will return with high economic security a computation result, and then also making it easier to, for example, integrate it to existing UVM applications, or even to, let's say, confirm a result early between Cartesi rollups, for example, because you can much quicker kind of like make sure that things are working correctly. So this is a very big topic at the moment with co-processors, and there's things like RISC-0 and so on out there as well. But I mean, if you have a co-processor, why don't you want to just run Linux on and write things in JavaScript? My joke with the presentation was that if you wanted to have a security budget of $5 billion and run PHP, this is how you do it.
So it's the compute narrative. So it's I understand that what we kind of did like 3 years ago is now becoming a hot topic.
Yes, but there's also, let's say, less delay in this particular case because you're not let's say optimistically proving, you're just, let's say, voting on the result in this particular
Yeah, that
case.
was I was about to ask that. So you don't
Yes,
in that scenario
basically off-chain computation, yes.
Yeah, you don't necessarily need arbitration, right? A dispute resolution on chain. You just perform computation in a deterministic way, and then you vote on the result. Is that it? Taking advantage of it.
Yeah, pretty much. I mean, you basically just go with the votes, like an aggregated signature, essentially, you get from the network.
That's a cool way of using Cartesi in a very simple way, straightforward. I like it. All right. Thanks a lot.
Yeah. Well, I think that's it.
Yeah, well, we have 10 minutes left. I was curious about one additional thing, but I'm not sure if it's doable. Please feel free to say it's not, Danilo. I was curious to see a demo of Cartesi scan with outputs showing output payloads. Is that possible? If it's not, then it's okay.
The bus just run Danilo over.
Oh, Danilo is there. He survived. He's Iron Man. He survived it.
I can try. Give me 1 minute.
Okay. Claudio, please entertain the people.
Okay.
Where's the other Claudio? He's so good at that.
Yeah. Claudio, come on.
Claudio Marcus, where are you?
It's not full roll. It's true.
Do you have the GraphQL URL in hand? I don't.
The GraphQL what?
Of the honeypot, for example.
Oh, just a second. I do. See if this is the one. It is.
Yeah. Can you see the screen?
We can.
Okay. So this is the Cartesi scan. On the home page, you can see the inputs. There are 18 inputs. You can see several deposits that we've been doing weekly to the honeypot. This is the amount of CTSI being deposited. This is the address of the honeypot dApp. No, sorry. This is the address of the honeypot dApp. So you can open and see the details of the input, right? This is the raw input, and there is a notices, reports, and vouchers tab here. you can't see anything unless you make a connection. So you click connection. This is you need to provide the endpoint of a GraphQL server of a reader node for the dApp. When you paste the URL, it tests the connection. And then you can see reports, notes, and vouchers working. In case of so this is very application specific, of course. Each application will define which notes, reports, and vouchers it's going to emit. In case of the honeypot, there is only one report when you do a deposit, and this report has a 0 value, meaning that the deposit was successful. So for the honeypot, this is pretty boring, but for real applications or some of the prototypes we have, there are a variety of notes, reports, and vouchers that now can be inspected through the Cartesi scan.
It's really cool. So Guilherme was asking if the connections are stored in local storage or cookies or something.
Yeah, the connections are stored on the local storage or in the browser. So there is no centralized entity holding these connections. So if you reload the page, come back another day, it's going to be stored in the local storage. You can delete the connection if you want, but this is not stored in a centralized manner.
Yeah, very nice.
Yeah, that's it.
Super Danilo
Thanks.
survived us incredibly well. Thanks, Danilo.
More questions, or can we close, Milton? Or you want to put someone else in front of the bus?
I think I've done enough for creating traffic jams for now.
Okay. Claudio, do you want to bring some closing words for our call? Give us the honor. I know you are here. Okay, guys. So let's close this call. It was a very nice call, many interesting updates. So we have a lot of content being shared on our social media. The market team is doing a nice work. DevEd team is also doing a beautiful work on events, preparing good documentation. Recently, we shared about a dev guide that is very nice. So please stay tuned, and any doubts, enter in our development community on Discord and share there your doubts, your comments, your ideas, especially because Cartesi is here to open the design space for the dApps that are the next generation of the dApps. So we want you experimenting using our tech, and we are here to give you support and bring all the information you need. Okay, so thank you and goodbye for everyone.